All right, so 6 was basically just the two theorems, right? The hinge theorem and then the converse to the hinge theorem. The hinge theorem says if the two pairs of sides are congruent and one angle is bigger than the other, then the side opposite the bigger angle is bigger than the side opposite the smaller angle. And then the converse says the reverse. If the two sides are marked as congruent and you know that the third side of one is bigger than the other, then the angle opposite third side is bigger than the angle opposite the smaller side. So this first one, and this literally just says to complete with less than, greater than, or equal to, you have to have your marked congruent symbols. So this one is congruent to this one is congruent to this one, and then you've got to have one more piece of information, which is the included angle. If 80 is bigger than 75, then KL is actually going to be less than LP, right? The smaller angle. If it wanted to know if that's the hinge or the converse, which one is it? Good, the original hinge theorem. So if it asks for Y, you'd have to give it.
Because you're trying to find the side.
Correct. All right, then the second, Yeah. The second one, you've got your 28 is congruent to 28, and then you've got your reflexive side. And then the two other sides given are 12 and 22. So because angle, this should be angle. Angle 1 is opposite the 12. Angle 2 is opposite the 22. Angle 1 is blank. Angle 2. Less than. And that would be hinge theorem converse. It's a typo. It's like when it converted it to the PDF, it did a weird thing with that. That should be in angle measurement. Questions? Okay. Oh, you said question what, 9? I didn't. Okay. All right. So what this gives you is... What this gives you is you've got one pair of sides here that are congruent, and then these, that would be reflexive, right? So what do we know about if these are congruent, what's true about those two sides? These would both be 2x, right? Like that? Yeah. Yes? So if you took, here's what you could do. The angle here is the exterior angle to this angle and this angle, which means it equals the sum of those two, right? And if these two have to be the same, it means it has to be greater than those angles. So then when you set up your relationship, you would have to say that this is greater than this. So 4x minus 3 is greater than 2x. And then subtract the 2x. No, subtract the 4x, sorry. Subtract the 4x. And I get negative 3 is greater than negative 2x. Switch your signs around because you're going to divide by a negative number. And you'd get x is greater than 3/2. Yep. Okay, so 6:1 to 6:6 is what your test is going to cover. Which again is Tuesday. Okay. We started with 6:1, 6:2, 6:3, which were on your quiz. 6:1 was these 4 theorems, well, converse and theorem and then converse and then theorem and then converse. Which the first one says the angle bisector theorem said if a point lies on the angle bisector, it's equidistant from the sides of the angle. So we would have an angle, we'd have the angle bisector, and then the two segments that would have to be perpendicular were the ones that were congruent. And then we said the converse to that, if the point is equidistant from the sides of the angle, then the angle lies, or then it lies on the angle bisector. So if you had that they were congruent first, then you would know that it lies on the angle bisector. Those both were in 6:1, the angle bisector theorem, and then its converse. Then came the perpendicular bisector theorem, and the perpendicular bisector theorem said if a point lies on the perpendicular bisector of the segment, then it's equidistant from the endpoints of the segment. So if I had a segment and then I had the perpendicular bisector of it, any point along this perpendicular bisector would be equidistant from the sides there. And then the converse to that said the reverse. If a point is equidistant from the endpoints of the segment, then it lies on the perpendicular bisector of that segment. So all of that came from 6:1. Then in 6:2 and 6:3, this is 6:2 and 6:3, we talked about the 4 special segments. All right, you've got your perpendicular bisector, which by definition is perpendicular to a side at its midpoint. The point of concurrency is the circumcenter. This is your in, on, out. If it's an acute triangle, it meets in. If it's a right triangle, it meets on. And if it's a obtuse triangle, it meets out. Specifically, if it's a right triangle, then it's the midpoint of the hypotenuse. So that's one of the points you could be asked to find. And then the theorem for the circumcenter says from the circumcenter to each vertex is congruent. So in that diagram, each of those highlighted segments from the circumcenter, which is the pink dot, to each vertex would be congruent. Then came the angle bisector, which bisects an angle. Its point of concurrency is called the incenter. They are always inside. And the theorem says from the incenter to the side is congruent. These have to have the little perpendicular marks. So, God bless you. From the incenter to each side would be congruent for these. So you'd have to know they're the angle bisectors or that it's the incenter, and then you would say each of those segments is congruent. Then came the median. So with the median, which goes from the vertex to the midpoint of the opposite side, they meet at the centroid. And again, always inside. And this is your 2/3 theorem. So from the side to the centroid is 2/3 the whole from the vertex to the centroid is 2/3 the whole segment. So this would be 2/3, and then this would be 1/3 of your segment. And then it's kind of blurry here, but to find the point or the coordinate point of a centroid, you add up the 3 vertices x's, divide by 3. You add up the 3 vertices y's, and you divide by 3. So that's also could be a point they ask you to find, the centroid of a triangle. Then you get the last one, which is altitude, and that's the perpendicular segment that goes from the vertex to the opposite side or the line containing the opposite side, because in an obtuse triangle it happens outside. The point where they meet is called the orthocenter. It is in, on, out. If it's the right triangle, then it's at the right angle, which is I think what was on your quiz, right? And there's no theorem attached to the altitude. Sure. So everything that's on here, I would say maybe even when it gets closer, like a Sunday, Monday, maybe I would even refill this information out to see if you could do it off the top of your head, because obviously it could ask you a question about any of that stuff. All right, so the mid segment is the segment that connects the midpoints of 2 sides of a triangle. So if I had a triangle, and I found the midpoint of each side, then the segment that connects them is the mid segment, sorry. And there would be 3 because there are 3 sides to a triangle. There. And there. Those would all be mid segments. Then we had the mid segment theorem. Which said the mid segment is parallel to the 3rd side and half its length. So this is where you'll either get given the mid segment and you have to find the length of the side, or you'll get given the side and you have to find the length of the mid segment. So for example, if I gave you, this was 5, what's this whole side? 10, and vice versa. If this is 12, what's this side? 6. Easy stuff, right? Sometimes you had like an expression and you had to say 2 times the small expression would equal the big one. Like that's kind of as far as this section went. Then came 6-5, which was inequalities in one triangle. All right, so 6-5 had these 2, right? The triangle longer side theorem, which says if one side of a triangle is longer than this other side, then the angle opposite the longer side is bigger than the angle opposite the smaller side. And then the triangle larger angle theorem, which we know information about the angles. If one angle is bigger than the other, then the side opposite the bigger one is bigger than the side opposite the smaller one. So you'll use these really just to put things in order. That's pretty much it, how you would see something like that. Here's a triangle. If it gives you the sides, then give the angles in order from least to greatest or greatest to least. Pay attention to how it says it. Or vice versa, if it gives you the angles, put the sides in order from least to greatest or greatest to least. So again, just pay attention to how it says it. And then we had our triangle inequality theorem, which says sum of any two sides must be greater than what?
Greater than the third side?
Good. So you'll get given three sides. You add the two smaller ones, see if they add up to be bigger than the third, okay? And then we had finding the possible side length. And for these, we say it has to be greater than the difference, but less than the sum. And then we ended with where we started the day, which was 6.6, the hinge theorem, and the converse to the hinge theorem. Okay, hinge theorem says if you know two pairs of sides are congruent and the angle between them, one's bigger than the other, then the one opposite, the bigger one, is bigger than the one opposite, the smaller one. And converse is if you get given two pairs of sides are congruent, and the third sides are one is bigger than the other, then the angle opposite is bigger than the angle opposite smaller. Questions? All right, so again, this is what your homework should be, okay, is to complete this, and then you can check it, the link on that, will at least give you most of them. I don't think it gives all of them, but it'll at least give you most of them, and then I'll post the solutions to it, okay? If I see you tomorrow, then we'll go over it tomorrow. If not, then I see you Monday, we'll go over it on Monday, okay? All right, we're going to play Quiz Alive.